So what's the one thing that connects, say, a software company struggling with latency and a factory that's trying out a brand new material? Well, it's this concept called technological uncertainty. And you know what? Understanding this is the absolute key to unlocking SR&D. So today, we're going to break down exactly what it is and, more importantly, how to spot it.
And that brings up a really critical question for any team out there. Is all that hard work you're putting in just a tough project, or is it actual R&D? I mean, getting this right can be a total game changer, and the answer really hinges on this one core idea.
All right, so let's get precise. What is technological uncertainty in this context? Because it's not just about hitting a difficult snag in a project. It's about drawing a really clear line in the sand between the routine, everyday problems and the truly unknown.
Here it is, plain and simple. Technological uncertainty is that very specific moment when even your top experts, the people with all the best tools and who know all the standard practices inside and out, still can't guarantee how a project will turn out technically. It's that point where the map just ends.
And this right here is the key distinction. On one side, you've got true uncertainty. This is a real tangled mess where the outcome is a genuine mystery. But on the other side, you've got routine problems. Now, don't get me wrong, they're hard for sure, but they're usually business challenges, things like project delays or just needing more people on a task. They aren't fundamental technological uncertainties.
So how can you spot this in your own work? Well, luckily, there's a pretty simple, practical litmus test you can use. Let's walk through the 3 telltale signs that you're dealing with the real deal.
Here they are in a nutshell. First, there's no known solution out there. Second, what you're facing isn't just a routine problem you've solved 100 times before. And third, and this one is so important, it absolutely requires experimentation. Let's break each of these down.
First up, there is no known solution. And this means you've really done your homework. You've scoured the manuals, you've dug through research papers, you've spent hours on forums, and you've picked the brains of every expert on your team. And what happened? You came up completely empty. There is simply no playbook for this problem.
For example, imagine you're testing a new compression algorithm. It's working great, but then it just starts crashing, totally at random, once you hit 3 gigabytes per second. So you search everywhere, online, in research, but nobody has documented this exact issue. That gap in public knowledge? That's it. That is true uncertainty.
Okay, sign number 2 kind of builds on this. The issue you're facing is not a routine engineering problem. A routine problem is something you recognize. You might not like the work, but you know the steps to fix it. This is completely different.
Think about it like this. A machine on the factory floor starts overheating. Does the maintenance team have a standard procedure to fix it? If they can just go down a checklist, replace a part, and get it running again, well, that's routine work. It's a solved problem, it's not uncertainty.
And this brings us to what is absolutely the most crucial sign of all. You are forced to experiment. If you can solve the problem on a whiteboard or with a quick calculation, it's not SR&D. The only path forward has to be a systematic process of trial, measurement, error, and discovery.
So let's say you want to use a new, cheaper resin in your manufacturing process. You can't just look up the answer. You have no idea how it's going to cure, if it's going to crack under pressure, or if it will completely clog and destroy your machines. The only way to find out is by methodically testing different ratios, playing with temperatures, and running trial after trial. That is experimentation.
Okay, let's see how this actually plays out in the real world. We're going to do some rapid-fire examples from 4 completely different industries just to show you how universal this whole concept really is.
First up, we're in the world of software with a classic performance headache, the latency spike mystery. Okay, so imagine a payment system that keeps having these random, costly slowdowns. The team tries everything in the standard playbook, they optimize the code, they upgrade the servers, they try all the usual caching tricks, but nothing works. So they're forced to experiment with entirely new architectures and data structures. That's SR&ED. Next up, let's head to the factory floor and talk about trying to create a new material formula.
So the business goal is super simple: save money by switching materials. But the technical unknowns? They are huge. How will this new stuff cure? Is it going to shrink? What's the viscosity like? The only way to de-risk this change is to run dozens of experiments, meticulously tweaking ratios, temperatures, and pressures to hopefully find a stable process.
Now for electronics, where we're going to try and push a device way, way beyond its intended limits.
So what's the goal? To make a printed circuit board run 3 times faster than its spec sheet says it can. And what happens? Well, suddenly, all the established rules just go out the window. You get unpredictable signal noise and all these heat problems that have no standard fix. The team basically has to start from scratch, experimenting with new layouts and shielding just to try and keep it stable.
And finally, an example from the food industry that is surprisingly complex, the quest for really good gluten-free bread. Now, the task sounds simple enough, right? But the scientific unknowns are immense. Without gluten, how in the world do you manage the dough's behavior and stop it from collapsing? The team has no choice but to run over 20 methodical trial batches, testing all sorts of different hydration levels and oven temperatures to even begin to find the answer.
Okay, so we've seen what it is and we've seen what it looks like. But why does this distinction really matter? Well, it all comes down to what I like to call the shop floor secret.
This quote right here, it gets to the very heart of it. From the outside, a factory or a production environment can look completely routine, right? Machines are humming, products are coming out. But underneath that surface, technical teams are constantly solving unpredictable problems and running these little hidden experiments all the time. That is experimental development.
And this brings us all the way back to you. Now that you know the 3 signs, I want you to think about your own projects. Try to look past all the routine tasks. Where are those moments of true, genuine unpredictability? Where is the hidden uncertainty in your work?